This is chapter 4, lesson 5, part B. So part 1 was I would have an equal sign. I would have like a plus sign. I would be adding fractions. And I needed to find the common denominator and then multiply every term by the common denominator. So actually, example 1 is a practice for us with this. And I'll first focus on finding the common denominator. Common denominator is the same as the least common multiple, LCM. Okay, my denominators are an x minus 3 and then a 4. So, help me out here. What's my common denominator? 4 and then x minus 3. Okay, I'm going to write, not too small, but everything needs to be multiplied by the 4 and the x minus 3. All right, so I'm going to cancel out diagonally what's the same. X minus 3, there. X minus 3 and x minus 3 in the middle. And a 4 and a 4 there. So that means that I'm going to get 4 times 3 first there, 12. X times 4 here, 4x. Minus, now I need to be really careful because I need to do x times x minus 3. All right, let's simplify and work it out. 12 equals 4x. Now I'm going to distribute the negative. Negative x times x, negative x squared. And negative x times negative 3, plus 3x. So 12 equals 7x minus x squared. So I have to make this into a trinomial. I also don't like that the x squared is negative because factoring out a negative is not like as easy. So if I move everything over to the right side, if I subtract 7x, and if I add x squared, then I would have a positive x squared leading the way, which would be really helpful to me. So I'm going to subtract the 7x, and then I'm going to add x squared. My trinomial, x squared minus 7x plus 12 equals 0. Okay, factor it. Two numbers that multiply to make 12 and add up to negative 7. X minus 4, x minus 3. That means I get x equals positive 4 and x equals positive 3. All right, checking for extraneous solutions means I cannot have the denominator be 0. And I look at my two answer choices. Maybe both of them work. Maybe not. But if I plug 4 in, 4 minus 3, that'd be fine. 4 minus 3, that'd be fine. I wouldn't have 0. If I plugged 3 in, 3 minus 3, that would be the problem. I cannot have 0 in the denominator. So 3 is extraneous. So x equals 4 is my answer. Okay. All right, so that was my first review problem. The next two are word problems. All right, if I'm doing a job and I'm going to work with Noelia and we're going to do some plumbing, we're going to build a fence, we're going to um, paint a wall, like this problem, whatever the job is, I could work really slow, and then Noelia works really fast, and we're gonna finish the job together. But obviously, she's gonna probably do more of the work, and she works faster. So if one person is slow and one person is fast, it's gonna change the dynamic of the job. You really want to be working with someone who pulls their own weight, right? You don't want to be with someone lazy. No one does. So what's happening is when you have a job together, you have to calculate mathematically. We calculate how long it would take us together versus alone. Let's say that this is Mrs. Grant, number one. Mrs. Grant together with Noelia, or Mrs. Grant alone, added to Noelia working together with me, or Noelia working alone. So our two efforts are added, and then we complete one job. This is always a one at the end, because you're doing one job. So this formula sets us up really easily so that we can calculate how long it would take each person. So I'm looking at this, and it says, Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. So Cheyenne is fast, Arthur is slow. It takes Arthur twice as long. How long would it take Cheyenne to paint the wall if she were working alone? Okay. Together over alone, together over alone. So in this example right here, I'm going to do Arthur. I'll call him Art and Shy. We're just abbreviating. Arthur together divided by Arthur alone, plus Cheyenne working together divided by Cheyenne alone, is one job. Now, I'm told in the problem, so I want to point out, they can paint the wall 6 hours when working together. Cheyenne works twice as fast as Arthur. Arthur is twice as slow, right? So what I need to think about is who's the faster person, because I need to make that person X. Who's faster? Let X equal Cheyenne. Cheyenne alone. I know that together they can do it in 6 hours. So I'm going to have Arthur 6 as my numerator and Cheyenne 6 as my numerator. That's already given to me. That won't be too difficult. But Arthur is twice as slow. Cheyenne is X. Cheyenne alone. The denominator for Cheyenne is alone. She's X. It takes Arthur double the time, right? Arthur's always, poor Arthur, we're really beating up on him. Arthur is double the time. Takes him twice as long. All right. If Arthur is double the time, like it takes him a long time, I'm going to put a 2x on Arthur alone. It's set up. We're ready to find our common denominator. We need to multiply everything by the common denominator. Okay? So, what's the LCM? Not just x. 2x. Okay, good. So I'm going to multiply Arthur by 2x, Cheyenne by 2x, and 1 times 2x. Cancel out anything you can. These two X's on Arthur cancel. An X on Cheyenne cancels. So 6 times 2. And then 1 times 2x is just 2x. So now just solve for x. X equals 9. Cheyenne can paint the wall. I'll do everything in cursive. Flashback elementary school. Okay. Cheyenne can paint the wall in 9 hours. And that's that. Okay. I'm going to turn the page. All right. So those of you watching the video, I'm going to stand up and explain using movements this to the class. So I'll maybe describe, I don't know. Well, I don't know. I might describe what I'm doing. It sounds kind of weird, but all right. So if I have a problem where I am canoeing in a river, kayaking in a river, rowing in a river, riding my bicycle in the wind, a plane is flying in the air, what's happening in the sky, the wind affects how fast or slow I go. So I am going to first start off by explaining against the current or upstream. It's also called a headwind. If I am going against the current or the wind is blowing towards me, so I'm here and I'm going to start at one end of the classroom and I'm going to row a boat or be on a bicycle or I'm going to be a plane flying. We just talked about against and upstream. So that means that the water is coming at me or the wind is blowing in my face. And so if I'm going to tackle that and ride my bike or canoe or be in a plane, flying a plane, the wind's coming against me and I'm trying to row my boat, ride my bike, whatever, it's going to be harder for me to get to where I want to go because the wind is coming against me or the water is rushing towards me. So I'm going to have to work twice as hard just to make any progress. So I'm working against the current. That is going to be described as an X minus a Y because two forces are working against each other. So now I'm going to stand up and I'm going to be with the wind. I'm going to be rowing downstream. It's also called a tailwind. A tailwind. So I'm on my bike or I'm rowing my boat or I'm flying a plane. The wind is going to be at my back or the water is going to be rushing with me. So as I'm rowing and riding, I can actually go a little bit faster because the water is pushing me along faster or the wind is pushing me. I don't have to work as hard. I could even let go and I'll still be moving because the water will carry me or the wind might push me a little. That would be nice. So I am working together with the wind. That's going to be described as an X plus Y. Now, my rate is going to be using this X minus Y or X plus Y. The time, we would have to specifically be told how long we rode or whatever. And the distance is going to be how far we went, right? So I've got Distance equals rate times time. I just wrote it backwards. All right. If distance equals rate times time, then time would be distance divided by rate. Okay. Here we go with the math problem. Paddling with the current in a river, Jake traveled 16 miles. Paddling with the current, he traveled 16. Let's fill that in on the chart. With the current, his distance was 15. I'm sorry, 16. Even though he paddled upstream for an hour longer, so I'm going to add 1 hour to the downstream because upstream was quicker or was shorter. Wait, upstream is always longer. What am I saying? I'm sorry, upstream is longer. If you're going upstream, the water is going against you. That's hard. That takes longer. So I have to add downstream is the shorter, quicker. I'm adding an hour to it to equal this long time that I have to go upstream. All right. So back up to the chart. I'm just documenting everything I'm reading. Jake could only travel 6 miles against the current. So go to against and put a 6 there for distance. Against 6. All right, what else? In still water, Jake paddles at a rate of 5 miles per hour. Okay. Up here in still water, he travels 5. I know still water. Still water is going to be a 5. I don't know how fast the current is going. So basically, instead of x, I'm going to put a 5. So for rate, it's not going to be x minus y. It's going to be 5 minus y because my still water is x, and that's 5. With downstream, or I also called it a tailwind, it's going to be the x plus y. But instead of x, let's put 5 plus y. It didn't say anything about time at all, which means I'm going to solve for the time. I don't know the time. I need to use that time equals distance over rate. Because if there's something that I don't know, I can't just put a t in my equation because I already have a y. I don't want two variables. All right. Time is distance over rate. So let's look at this top one, guys. The distance is 6 and the rate is 5 minus y. Distance divided by rate. 6 in the numerator, 5 minus y in the denominator. For width and downstream, distance is 16. 5 plus y is in the denominator. So here's what's going to happen. I'm going to do the time downstream equals to the time upstream. I cannot forget that I'm adding an hour down here, adding an hour to downstream because the upstream is longer, takes longer upstream. The time downstream is 16 over 5 plus y. I'm adding 1 hour to downstream plus 1 hour. Remember, this is time. So it's longer downstream plus 1 hour. Now, time upstream, right here, 6 over 5 minus y. 6 over 5 minus y equals 6 over 5 minus y. Okay, this requires me to still find the common denominator, multiply everything by the common denominator. So here's what's going to happen. I am going to write down all the steps, and I encourage you to pause the video so that you can catch up with my writing. So here we go. If my common denominator is, okay, LCM, it has to be both of these. 5 plus y, 5 minus y. I'm going to multiply every term by my common denominator. 5 plus y, 5 minus y. 1 times 5 plus y, 5 minus y. This side, the 6 over 5 plus y, 5 minus y. I'm going to cancel out the 5 plus y's, which gets me 16, 5 minus y. Okay, the 1, you guys, what's 5y times 5 minus y times 1? Isn't that like a special thing in factoring? It's a difference of squares. 25 minus y squared. And then I can cancel out this 5 minus y and this 5 minus y. 6 times 5 plus y. Okay, here we go. Distributing what I can. 80 minus 16y plus 25 minus y squared equals 30 plus 6y. So this is me. Let's get everything, the y squared. I really do want it to be positive. I'm just going to move everything over to the right. Subtract 80. Add 16y. Subtract 25. Add y squared. Lucky you. I'm going to do it all for you. Here's what you end up with. Everything on the right, a positive y squared plus 22y minus 75. I factor that. Make things a trinomial when you can. It's y plus 25 and y minus 3. So this is like zero product property. I set each thing equal to 0 because I want to know, are both of these going to work? How can both, this is my time I'm talking about. How long, right? The question, I'm sorry, what is the speed of the current in the river? That's what it's asking us. What is the speed of the current? To find the time, I would plug in the correct answer. So y equals negative 25. Can I say that the water was going negative 25 miles per hour? Can anything be negative when you're talking about speed? No. This is my extraneous solution. I can't have a negative number. Currents can't be negative. 3 is the correct answer. Y equals 3. The current is 3 miles per hour. turn the page on homework. Please cross out number 4. It's a work problem. You're not doing that one. That's just too much. Too much. Cross out number 4, the painter. Cross out number 4, the painter. But everything else you are responsible for doing. I'm going to stop the video.